Hello everyone, I hope you're doing well. In this video, we're going to take a look at properties of water. To help us look at properties of water, I want to frame these notes with this question. This was a question that was very popular. Go ahead and take a second to think for yourself. Is water wet? This debate isn't as popular as it used to be, but I think it's still pretty interesting. And the answer to this question really depends on your definition of what it means to be wet. All right, so we're going to answer this question using these notes and using properties of water to explain why we have chosen our answer. Okay, but before we do that, we want to go through these slides to look at the unique properties of water, again, to help us answer the question, is water wet? So we're going to go through the different properties of water, and then towards the end, I'll circle back to this question. I'll give you my answer and explain why. All right, so these are the properties of water. To me, there are 9 of them. Depending on where you look, there could be more or less properties of water. Some of them could be combined. Some of them could be split apart. So depending on where you look, there could be a different number of properties of water. This is the best way to think about it, in my opinion. Okay, so first up, the first property of water. Water is known as the universal solvent. Okay, so over here we have an image depicting sodium chloride dissolving in water. All right, the sodium chloride is what gets dissolved. That's known as the solute. The water does the dissolving. The thing that does the dissolving is called the solvent. So water is known as the universal solvent. It can't dissolve everything, but it can dissolve a lot more than basically every other solvent. Because of this, water is known as the universal solvent. Up next, we have polarity, and this should be familiar to you from intermolecular forces. Water is a polar covalent molecule, meaning the electrons are shared, but they are not shared equally. Oxygen is way more electronegative here, so oxygen is going to end up with a partial negative charge, and hydrogen is going to end up with partial positive charges. This is going to make the compound itself act like a magnet and bring forth all sorts of different properties for water. The first being hydrogen bonding. And again, you should also remember this from intermolecular forces. This is a very strong type of bond that can be made between hydrogen and a few select elements. Oxygen is one of those elements, so water exhibits hydrogen bonding. Notice the negative oxygen is always pointed to or attracted to positive hydrogens, all right, and vice versa. The third property of water is cohesion. Cohesion is the sticking together of two like substances. This picture over here does a great job of showing us what cohesion is. Cohesion is water stuck to more water. All right, and the reason this happens is, yep, you guessed it, hydrogen bonds. This image also does a great job of comparing cohesion with adhesion. Cohesion is water stuck to water. Adhesion is water stuck to not water. All right, most often in real world or in nature, water is going to be stuck to some sort of plant life. That's what we have here. The next property is capillary action. Due to cohesion and adhesion, water can do this cool thing called capillary action. This is when water moves through a narrow tube, right? Like the narrow tubes in this celery stalk, and the water can even move against gravity and get up to the leaves. All right, so this image is showing us these celery stalks sitting in what we assume is water with food coloring. How did the food coloring dye get to the leaves? It traveled up through the narrow tubes in the celery through capillary action. Up next is surface tension. This is probably the trickiest to understand, and I'm going to do my best to explain this to you in a way that makes sense. So we know that water wants to stick to other water molecules. This is known as cohesion. And cohesion happens because of hydrogen bonds. So let's assume for a second we have this glass of water. And there are all these water molecules in it, right? And are these water molecules attracted to each other? Yeah, they are. The water molecules are being pulled in all sorts of different directions by the other water molecules because of hydrogen bonding. That's true throughout this sample of water, except for the very top layer. All right, these molecules are super tiny, so it's hard to picture a one molecule thin layer, but eventually at the very top of water, you're gonna have one molecule thin of layer of water, okay? So these molecules up here, this is the very top edge of the water. And they are pulled in all sorts of different directions except for up, right? They are not pulled up because what's above this very top layer of water molecules? It's air. All right, so because these water molecules are not pulled up, their bonds in the right and left direction are way stronger. And this is what creates surface tension. And surface tension is why, if you've ever done a belly flop into water, it hurts. All right, surface tension is also why small insects like this water strider here can essentially stand on water. Up next is heat capacity. We will talk way more in depth about heat capacity when we get to thermochem. All you need to know right now is heat capacity, or also known as the specific heat of a substance. It's how much energy that substance can absorb before the temperature starts to change. All right, I like to think of it as a resistance to heat change. Water has an abnormally high specific heat, which means it can absorb large amounts of energy without changing its temperature very much. This is due to the hydrogen bonds. Those hydrogen bonds can absorb a lot of energy. Water's high specific heat is very helpful to us in terms of regulating the temperature on Earth. It's also why it's typically pretty breezy by the beach, right? There's a temperature difference over land and over water because, again, water can absorb a lot of energy. Property number 8 is density. This is probably the weirdest property for water. Most substances will become more dense when they go from liquid to solid. Okay, those substances become more dense because the atoms get closer together. The molecules get closer together. Water is a weird one where the molecules actually spread out as it goes from liquid to solid. Because of that, solid water, aka ice, floats. This is very helpful to the fishes and the frogs and the plants that live in areas where water freezes, okay? Because ice floats, only the top layer is going to be frozen, which allows those fish, let me draw a fish, there we go, which allows the fish and the plants to survive underneath while the top layer is frozen. Okay, here's another image for density. This is what liquid water looks like, and notice as we move to the solid state, the atoms, or the molecules get farther apart. Finally, water is known as a requirement for life. As far as we know, life cannot exist without water. Additionally, water is used as a solvent for all the chemical reactions that happen inside living organisms, and many of the other properties listed provide essential benefit to life on Earth, like heat capacity. Alrighty, so that's it for the 9 properties of water. You really just need to be familiar with them, familiar with a definition of the term, and maybe an example. The questions on your assignment talk about ball and stick models. This is a ball and stick model for H2O. You're going to want to draw some of these and make sure you indicate the partial positive and partial negative charges, okay? That polarity is important. So back to our initial question. Is water wet? If we assume the definition is water being on or in something, water is in fact wet, because water is almost always going to be stuck to other water molecules. Okay, so for me, because of polarity, because of hydrogen bonding, because of cohesion, water is in fact wet. All right, but that's going to depend on who you ask, whether or not they think water is wet. And again, it all comes down to the definition of the term. Fun fact, an argument or a discussion about the definition of a term is called semantics. There you go. There's your SAT word for today. And that's it for these notes. If you have any questions, let me know. Have a great day.